And good day, everyone. Once again, we are back together. And this time, we'll be looking at question 10, still on Euclidean geometry. And, sometimes people find this section a little bit intimidating. And I want to say that, if you do find it intimidating, perhaps when you approach a question paper, perhaps this is the last part that you'd like to visit, right? So that it doesn't really discourage you, so that you can do well on the other sections with confidence, okay? But let's show you that actually it is quite doable. It is a little bit on the intimidating side, this one. So if I were you, I would leave this right up to the last minute, okay? Well, not the last minute, but at least there's the last question that you should answer. Right, so they say to us, in the diagram, PQRS is a cyclic quad. They've given us KP there, which is a tangent, okay, to the circle at P, right? And they give us C and D, which are points on the chord, all right? And PQ and PS, respectively, and CD produced meets RS produced at A. Right, so that's a whole lot of information that we're given, all right? And obviously to try and assist us to understand this question. Now, for me, every time that I read a statement, I always find myself asking, how is this relevant to me, right? How am I going to use it in the diagram? So what I normally do is I pick up information, I will try and populate as much as I possibly can. Right, so they say CA is parallel to QS, and we're given the RC, which is drawn such that P1 and R2 are equal. Right, now let's start. Now, what I normally like to do is, just name or label, angles, right? They've already told me that these two angles, P1 and R2, are equal. So I'll start there. Let me call those angle X, right? And therefore that means this will be angle X, right? Now I'm going to look for any other angle, right, that is equal to X. All right, so I can see I can use 10 chord theorem. It means that Q1 would also be X as well, right? And then which other angles would be equal to X, right? I can see I can also actually say that just using corresponding angles there. Okay, so I can actually find another angle that is X. Actually, I just saw it now. Not sure where. Yeah, there we go. C1. C1 would be X. Yeah, that's the one I wanted to actually talk about using corresponding angles as well, right? Now, I'm not sure if there's any other angle that you see that might be equal to X, right? I am just simply going to leverage on that cyclic quad issue there, right? So I'm going to find another angle. Okay, so I'm going to label this angle. I'm going to call it Y, right? And in this case, let's find another angle equal to Y. If we use the exterior angle of a cyclic quad, that means this entire angle would be equal to Y, right? And this makes angle Q2, okay, this little angle over there, let me just use a different color. So this little angle over here becomes Y minus X. Remember, Y is that entire angle over there, right? Now, if I look at, in this case, T2, it would be the exterior angle of this triangle here, right? So if I take the value of T2, okay, so that will be, remember the exterior angle is equal to the sum of the opposite interior angle. So T2 would be equal to R2 plus Q2, right? And so that would give me X, R2 is X, and Q2 is Y minus X. And so that means that that would be Y as well. So that means this angle here would also be equal to Y. Okay, that angle there equal to Y. And look at that. using corresponding angles, that means that is equal to y as well, right? Okay, so I think we've tried to populate as much as we possibly can. Of course, the others will be 180 minus y's and 180 minus x plus y, and so on and so forth. Now, let's go on to answer the question. They say prove giving reasons that S1 is equal to T2. Okay, let's look at that. S1, okay, so S1 is this guy here that we called Y, is equal to T2. Okay, so we've already somewhat, we've done that already, right? So we can say, well, let S1 actually be Y. S1 equal Y, right? So in this case, what we said is S1 is equal to Q1 plus 2. So S1 is equal to Q1 plus Q2. Okay, so in this case, remember, why did we say they are equal to each other? That's the exterior angle of a cyclic quad, right? So that's the exterior angle of a cyclic quad, right? And then in this case, we said, right, but we know that angle P1 is equal to R2, right? Which was already given. Okay, but we know that P1 is equal to R2, okay, which was already given. Okay, that was given to us. All right, and so we said that will be equal to x. Okay, so we called that x. Now, in this case, we said that Q1 was equal to we said, looking at those angles, that actually also makes Q1 equal to P1, and we used, so P1 is equal to Q1, right? So we said is equal to Q1, and we said that is the 10 chord theorem, right? So that became, those two became equal to each other by virtue of the 10 chord theorem, so which is also equal to x, right? Now, note in this case that we said Q1 and Q2 is y, right? Now let's go to T2, right? So we said, looking at T2, that is going to be the exterior angle of that triangle RTQ, right? So in triangle RTQ, right, we know that T2, right, is equal to R, so we said that's going to be equal to R2 plus Q2. Okay, so that's R2 plus Q2. All right, so remember, why did we say that? We said that's the exterior angle of a triangle. Okay, right, now please, I want you to note what I did in this case. Remember, we're trying to prove that T2 is equal to S1, right? So in this case, we said T2 is equal to R2, but remember, we called R2 X, right? So that becomes X, and Q2, remember that Q2 plus Q1, that's equal to Y, right? But in this case, we're looking for Q2, right? So in the, I want you to remember that Q1 is equal to X. So in this case, this is X and this is Y. So we can say that Q2 is actually Y minus X, right? So we know that Q2 is Y minus X. Okay, right. So in this case, we can say, therefore, that T2 would be equal to X plus Y minus X will be equal to Y. Okay, so note T2 is equal to Y, but also we remember that, that angle S1 is also equal to Y. So therefore, it means that S1 will be equal to T2. I hope that made sense, ladies and gents. I know that's a lot of X and Y's in there, but I hope it somewhat made sense. All right, now they say to us, we also need to prove that AD over AR is equal to, so that's AD over AR, okay, is equal to AS over AC. Okay, right. Now it does look like they are actually looking at that big triangle there, which is ARC, isn't it? Okay, right. So now we need to find out, is there any other triangle that is similar to that triangle there, ACR? Okay, right. Now, I want you to please note in this case, right? If I look at, so we already have this angle here equal to that. Okay, we've proven that. Okay, so is it possible for us to prove a similarity between the two triangles ARC as well as ASD? So meaning this triangle here, okay, and that big triangle, maybe let me use a different color, okay, and that triangle over there, right? And the reason for that is that already I've got a common side and I've got two other angles that are equal, right? So in that case, it would mean that obviously the third angle would therefore be equal, right? And it means those two triangles would therefore be similar. So for 10.2, okay, so let's keep with a consistent color, right? So for 10.2, I am simply going to say, right, I am working with those two triangles there. So I'm going to say in triangle, okay, we said triangle ARC, right? So in triangle ARC, which is the big one, and triangle ASD, right? ASD, and we must always make sure that it's the corresponding vertices. We label them according to the corresponding vertices. Right, now, firstly, we proved from the previous one that S1 was equal to T2, right? We've already proven that. Okay, so in the two triangles, so these angles S1 and T2 rather, T2, where is that? Yeah, there it is. Okay, those were equal. Also making, in this case, because of alternating angles, oh yeah, I forgot, I actually spoke about T2 instead of C2. Now note, in this case, it means that T2, right, will be equal to C2. Can you see that? So that's proven. So T2 is equal to C2, and in this case, that's because of alternating angles, right? So therefore, it means that S1 will therefore become equal to C2. So S1 will be equal to C2. So I was trying to prove that those two angles are equal. I'd forgotten that I actually did that, whilst labeling the diagram. So I've got these two angles equal now, right? What other angle is equal? Of course, A is a common angle. So in this case, A is equal to A, which is common, right? So that's a common angle between the two triangles. Now, it therefore means, obviously, the third angle, right, would therefore be equal. So what does that mean? It means that D1 would therefore be equal to R1, right? So, therefore, it means that D1 will be equal to R1. And in this case, you can just simply say angles on a triangle, right? So now we need to make sure that when we label that, okay, it's in accordance to, the vertices as they appear, so that we don't make an error there. So if I say, well, a triangle ASD, so I'm starting at vertex A to that angle Y, to the other angle. So triangle ASD, right? So therefore triangle ASD is similar to triangle again. So I'm going to start at A, right? Because those are the two angles that are equal, right? And then, so AS in this case, that would be AC in this case, right? Remember, angle S is equal to angle C, right? So that will be ACR. Okay, so that will be ACR. Okay, so now please remember, so when we use similarity, so we know that AS, right? If the triangles are similar, therefore it means that their sides are also proportional, isn't it? So in this case, we're going to simply say, well, AS over, okay, let's see, over AC, right, is equal to SD over CR, which is equal to AD over AR. Okay, but we were interested, we are looking at, they said AD over AR. Okay, so AD over AR, which is this one here. And then we also wanted AS over AC, which is this one here. So there it is, we've proven it. Okay, so it means that AS over AC is equal to AD over AR. Okay, right, and there it is, ladies and gents. We have proven there. So you can actually just state there that the corresponding sides of a triangle, in this case, are proportional. Okay, right, now let's go on to the next question. Right, so they say to us in our next question, they say we must prove that AC times SD. Now these can be a little bit on the intimidating side, ladies and gents, but believe you me, if you're just systematic about it, you can get lucky and get it. But if you don't, we've already gotten those 4 marks just with similarity and, just understanding how to prove similarity, right? Okay, so they say to us, prove that AC times SD is equal to AR times TC. Now, if I look at that, ladies and gents, I already have something that I've proven there, right? So why can I not just use what I've already proven in the previous statement, right? Use that to try and prove what is given to me there, right? So remember, what do I have? I've got AS, there it is at the bottom there. We said we've got AS, right, over AR, AS over AC rather, okay, which is equal to AD over AR. But we must also keep in mind that we've got that as well, right? We've got SD over CR. And the reason why I'm mentioning that is that I see that AR sort of appearing there, okay? But I also see that SD as well, right? So if you don't mind, let's take, so for 10.3 rather, let's take from our previous proof, right? I'm going to take AS over AC, right? And remember, this is equal to AD over AR, but in this case, I'm not going to use that one because I see there's a CR there. Okay. So In fact, there's an SD rather. So I'm going to take this one here, right? I'm going to take this one here. So I'm going to say SD over CR. Okay, so now let's try and cross multiply. So AS multiplied by CR is equal to AC times SD, right? So we know we are somewhat close in this case because we do have AC and SD, right? Now what we need to deal with is this guy here, right? So what is not there is that CR there. So I need to find a way to somewhat get rid of this AS because it's not in our final equation, right? So it's not there. So I'm going to make AS the subject of the formula, all right, so that I can find something else that is equivalent to AS that would somewhat get rid of it. Okay, so I'm going to say, well, AS, right, would be equal to, so I'm going to divide by CR on both sides. Okay, so I'm going to have AC, so that cancels with that, times SD over CR. Okay, so that's the first one, right? Let's call this equation 1, right? Now, what we can do, now you remember that we also have something else in that, right? Okay, so I'm going to try and erase some things here so that you can see it. Okay, so if I go back to the very same thing, right? You remember that in the big triangle, right? So in this big triangle here, right? So I still have, in this case, those parallel lines, right? And what do we know? We know that if, the third side, if a line is parallel to the third side of a triangle, then what does it do? It breaks the other sides in proportion, right? So what I'm going to do is I'm going to go to triangle ARC again, right? So in triangle ARC, or you can say ACR, okay? So in triangle ARC, right? I know in this case that if I take, let's look at it. So if I take AS, for instance, yeah, so if I take this side over that entire side, okay, and I'm taking that one because there is a common side to the other triangle, right? Remember, what am I trying to look at? I'm looking at AS, right? I'm trying to isolate that AS. So I'm going to say AS over AR, right? In this case, that would be equal to, now on the other side, remember, so AS over AR would be CT, right, over CR. Okay, now let me try and erase so that you can see what I'm talking about. Okay, so all I'm simply saying is AS over AR, right, would be equal to CT over CR. Okay, and why? Remember that CR is there again, and as well as that AS again. So I said, looking at this, I've got AS over AR, which is equal to CT, right? So we said CT over CR. Okay, so that's CT over CR, right? And remember, what was the reason, right? We said this is line that is parallel to the one side of a triangle, okay? Of a triangle, okay? Or you can just simply say this is the proportionality theorem, okay? Right. Now, ladies and gents, I am going to isolate. Remember, what did I make subject of the formula here? AS, I'm going to do the same here. So that means that AS would be equal to AR times CT over CR. Okay, now because I've got two equations that represent, so let me call this equation 2. So what does that mean? Equation 1 is equal to equation 2. And now I've got AC times SD, AC times SD over CR is equal to AR times CT over CR. Okay, now of course we can drop those denominators in this case, right? And once we drop those denominators, we are left with AC times SD is equal to AR times CT. And in this case, that is what they had asked us to prove there. Okay, you can call it CT or TC, it's still the same thing. Right, I hope that made sense, ladies and gents. I know, as I said, these can be slightly intimidating, but that is how the cookie crumbles, and I know you guys will do well. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.